Welcome to the DIY Honda Garage channel. The DTC P2DE0 stands for Cold Start Air-Fuel Ratio Control System, lean, indicating that the engine's actual air-fuel ratio is leaner than what the Powertrain Control Module, PCM, commands. This situation usually arises when there is not enough fuel in the air mixture during cold starts, leading to inefficient combustion and potentially increased emissions. The PCM is the vehicle's onboard computer that monitors and controls the engine conditions. And it uses various sensors to determine the correct air-fuel mixture. If it detects that the lean condition persists, it will store this trouble code to aid in diagnostic procedures. Understanding the importance of the air-fuel mixture is crucial, as an incorrect mixture can affect engine performance and longevity. The following slides will outline the necessary components involved, possible causes of this error, symptoms to look for, and detailed troubleshooting steps. The main components related to DTC P2DE0 include the Powertrain Control Module, PCM, which is responsible for regulating engine operation, and the Mass Airflow, MAF sensor, which measures the volume and density of air entering the engine. The Air Fuel Sensor, AF sensor, plays a critical role by adjusting the fuel mixture based on readings from the exhaust system. Another important component is the Positive Crankcase Ventilation, PCV valve, which helps manage crankcase gases and maintain optimal pressure. The fuel feed line distributes fuel from the tank to the engine, while the exhaust gas recirculation, EGR system, although not specifically mentioned, can also influence air-fuel ratios. Each of these components is located in specific areas. For instance, the MAF and AF sensors are typically found near the intake manifold. A proper understanding of these components will help in diagnosing the lean air-fuel ratio problem. Several potential causes may lead to DTC P2DE0 being triggered. One of the most common causes is vacuum leaks in the intake system, which can allow excess air into the engine, resulting in a lean air-fuel mixture. Another possibility is faulty readings from the MAF sensor, which can misrepresent the amount of air received by the engine. Blocked fuel injectors can restrict the fuel flow necessary for proper combustion, while a dirty air filter can limit airflow and disrupt the air-fuel balance as well. Additionally, a defective AF sensor can contribute to incorrect fuel adjustments, compounding the lean ratio issue. Each of these causes affects how air and fuel mix in the engine, leading the PCM to register the fault. Drivers may notice a variety of symptoms associated with DTC P2DE. A noticeable symptom is reduced engine performance, as a lean air-fuel mixture often results in insufficient power output. Poor fuel economy may also be observed, indicating that the engine struggles to operate efficiently under these conditions. Additionally, rough idling can occur, characterized by fluctuating engine speeds while at a stop. Increased emissions may be evident due to incomplete combustion, which compromises environmental standards. Most notably, the check engine light will illuminate, alerting the driver to an issue that requires immediate attention. Recognizing these symptoms can guide diagnostics and repairs effectively. The first step in troubleshooting DTC P2DE0 involves ensuring that the engine has cooled down sufficiently to 77 degrees Fahrenheit, 25 degrees Celsius or less. By allowing the engine to reach this temperature, technicians minimize the likelihood of false readings from sensors influenced by heat. Once cooled, the next step is to check the engine coolant temperature, ECT sensor 1 value. This sensor is critical as it relays information regarding the coolant temperature, which affects engine performance, including the air-fuel mixture calculations executed by the PCM. Confirming that this sensor reads proper parameters ensures diagnostics will proceed on accurate grounds. This foundational step sets the stage for any necessary deeper inspections into the vehicle's fuel and air systems. In the second step of the troubleshooting process, start the engine after it has cooled and let it idle for a minimum of 10 seconds. This step is crucial for determining whether the DTC P2DE0 reoccurs under these operating conditions. During this idle period, it is essential to monitor the engine's performance and the data readings from the relevant sensors. If the DTC reappears, it indicates that a persistent issue within the air-fuel control system may still be present. This idle check allows technicians to gather real-time data that may pinpoint specific components or systems responsible for the lean condition. As a next step, you should compare the current air-fuel mixture to the commanded values maintained by the PCM. After the troubleshooting and repairs are completed, it is crucial to perform final repair verification to ensure the issue has been resolved. Start by clearing the DTC from the vehicle's computer system via the diagnostic tool. After clearing the code, take the vehicle for a test drive under various conditions to evaluate if the engine operates normally without re-registering the fault. This test drive is essential to confirm that any previously detected lean conditions have been successfully remedied. Pay attention to any signs of rough idling, reduced performance, or unusual sounds during the drive. If everything operates smoothly, you can confidently conclude that the repair was successful, ensuring your Honda CR-V runs efficiently. To prevent reoccurrence of DTC P2DE0, regular maintenance of essential engine components is critical. Begin with routine inspections of the air filter to ensure that it is clean and allowing unobstructed airflow to the engine. A clogged filter can lead to a restricted intake, contributing to air-fuel ratio problems. Additionally, fuel injectors should be checked for clogs and consistent performance to ensure they deliver the correct amount of fuel. Monitoring vacuum lines for any signs of wear or potential leaks is vital, as these leaks can drastically affect the air-fuel balance. Also, consider periodic checks of the MAF and AF sensors to confirm their reliability. Implementing these maintenance measures can help ensure your Honda CR-V operates at peak efficiency while mitigating any risk of future DTCs. In conclusion, understanding the implications of DTC P2DE0 is essential for maintaining your Honda CR-V. This code denotes a lean air-fuel ratio condition, which can adversely affect engine performance and emissions. It is crucial to approach troubleshooting methodically, starting with ensuring the engine's cool temperature and monitoring relevant sensor outputs. Following systematic steps fosters effective identification and resolution of any underlying issues. Equally important are preventive maintenance practices that can mitigate the risk of this DTC reappearing in the future. By staying attentive to these recommendations, vehicle owners will contribute to their car's longevity and performance, ensuring a more reliable driving experience. Please like and subscribe to the channel. See you next time.